Hi, this is Sean Moran with ACC GIS, and this is Introduction to Geospatial Data. We teach this course because data is at the core of what GIS professionals do. As shown on your screen, you can see that we take data, turn it into information which leads to knowledge, wisdom, and insight. Every GIS professional starts with these unstructured observations we call data, and we turn them into information by taking those observations and structuring them into facts. Knowledge is arranging those facts and the connections between them. And then we use analysis to better understand or come to a deeper knowing of which facts are most important in those connections between them. Ultimately, that leads to insight. Insight is the deepest level of knowing. It's understanding the essence of the data that we are looking at and how that applies to our analysis. So as always, we'll start with the data. By the end of this topic, you'll be able to explain the relationship between data, information, and knowledge, define data, differentiate between primary and secondary data, explain nominal, ordered, interval, and ratio data types, and describe how tables are structured. Data is from the Latin plural for datum, also known as a fact. Now this is interesting because in the GIS profession, we also use the word datum to describe how we model the Earth, and it's the basis for all of our coordinate systems. But in this context, we're just referring to a fact. And in its plural, data are facts collected for references or analyses. Now we collect these facts through our own observations or experience, that's known as primary data, or from some other source. We refer to that as secondary data. Now primary data is data created by you, whereas secondary data is data created by someone else. So for example, if I go out to the field and record a bird call, I'm creating primary data. But if I go to the internet and I download an audio file of a dove call, that is secondary data that somebody else has collected and I'm using. Same goes for like taking a picture or producing a documentary or writing an autobiography. If I do that, that's primary data. But if I collect this data from the internet or from some other source, that's secondary data. Likewise, as GIS professionals, if we go out in the field and we collect measurements or data, that's primary data collection. But if we're using a published data set, say from the census or FEMA, that's a secondary data set. Now, primary data sets are really great because they're very specific to your needs and you can control the quality. Whereas with secondary data, you kind of have to adapt your needs to the secondary data set and you have to accept the quality of that data set. But the kicker is primary data is very expensive to collect. It requires a lot more resources, whereas secondary data requires less resources. I'll also say that sometimes secondary data is preferred because you're going to the authority on that data set. And so if I'm using census data or FEMA data, sometimes my audience will trust that data than if I collected the data myself. Now, once we collect that data, we store it by imposing a pattern on it. For example, true or false. So if I have a room that is full of dogs and cats, that's just animals. But if I impose a pattern on that, for example, that these animals are cats and these animals are dogs, I'm basically imposing a binary pattern on that information. And that binary pattern is referred to as a bit, and it's the smallest unit of data, a 0 or a 1. And then we store those bits collectively to store more complex data like video, images, sound, text, and numbers. And you can see that screenshot of the iPhone. There are all kinds of apps there, some that store videos, for example, like the camera app that stores images, or maybe there's an audio app where you can listen to music, you can type text in your email app, and you can use the calculator for numbers. So there are all different ways in which we store and then ultimately utilize that data. Now, when we're storing data, a bit is just a 0 or a 1. And here you can see a bit on your screen right there. Now, we put together these bits to create a byte, and 8 bits make a byte, and then that byte can be used to store more complex information that's not necessarily just binary. So for example, the capital letter A is made up of these 8 bits, 0, 1, 0, 0, 0, 0, 0, 1. And that makes the capital letter A. Now we add up these bytes to create higher and higher and more complex data sets and larger data sets as well. And so if you look down at the matrix below, you can see that if 8 bits lead to a byte, then 1024 bytes lead to a kilobyte. And the way to think about this, even though it's more correct to be 1024 bytes leads to a byte, if you think about it kind of like as the metric system, in that 1,000 bytes leads to a kilobyte, then it's easy to remember, for example, that 1,000 kilobytes equal a megabyte, 1,000 megabytes equal a gigabyte, and 1,000 gigabytes equal a terabyte. And you can see by the examples on the right-hand side of your screen that as the size increases, the complexity of the data and the amount of data you can store increases as well. I can go buy a 1 terabyte thumb drive at Office Depot, for example, and I can store 400,000 large books of text in them. That's really amazing.